Hello everyone, welcome back in Skolarhive. So in this today video, I'm going to start the algebraic identities, which is a part of the polynomial, which helps us in simplifying the typical polynomial or expression with the help of the identities. And also it will help in the further lecture, like when we learn the factorizations of the polynomial with the help of identities. Okay, so let me start with the very basic identities. The first one, that is, if we have the squares of the sum of two numbers, let's say the numbers are a and b, squares of a and b, this is given by a square plus 2ab plus b square. So this is the result. We need to remember this and we can use this result whenever it is required. And how these things are come into existence, just try to understand first. If we are writing this a plus b whole power 2, what does it mean? It means a plus b multiplied itself 2 times. And when you use the distributive property over here, we'll get this as a times of a plus b, then plus b times of a plus b. If we further expand it, this will become a square plus ab plus ba plus b square. Now ab and ba both are same, as a and b are the numbers we are taking over here, real number. Then a into b and b into a both are same by the commutative property. So we can write this as a square plus 2ab plus b square. So this is the way we are finding that the squares of sum of any two number is equal to a square of first plus 2 times of the product of 2 plus a square of the second number. Now similarly, if we do have given as the difference of two numbers, let's say a minus b whole power 2, then we can find that this result is given by a square minus 2ab plus b square. So like I found the result of a plus b whole square by using the multiplications. We can find the a minus b whole power 2 as well. So we can write this a minus b whole power 2 as a minus b times of a minus b, and we can further distribute this as a times of a minus b and then minus b times of a minus b, which will give us a square minus ab minus ba plus of b square. When you multiply this, okay, you'll get this result. Again, ba and ab both are same, so we can write this as a square minus 2ab plus b square. So this is the two basic identities that we are using. This is what we have derived this result. We'll use this whenever it is required. Okay, so we need not to just remember a plus b whole square is equal to a square plus 2b plus b square, but also we need to remember from right to left as well. When we have a square plus 2ab plus b square, we can think of this is equal to a plus b whole square also. Here one thing we need to observe, that this order of these things does not matter. In some of the book you will find that it is written as a square plus b square plus 2ab. It does not matter the order of this, because you know the commutative properties of additions and multiplication, right? So this is what the very basic identity a plus b whole square and a minus b whole square. Let's try to understand this geometrically. What does it mean? What does a plus b whole square means? Think of, this is a square of some number. Let's consider this a plus b as some number. So it means what? This is a square of some number. Means a square of some number, if we talk about the square, geometrical figure square, means a squares of the sides of any square is given as what? The area of the square. So let me just take a square of side a plus b. This is, let's say, a, and this is b. If I'm taking a square of side a plus b, what we'll get? We'll get this as, over here this is a, and here also I'm taking b. This is b. So like this, if I'm forming the square, we'll get this as, okay, once we complete this, we'll find that this is a square of side a plus b. Okay, now this is a square. See, this side is what? A plus b. So this whole region is nothing but the area of this square, a plus b whole square, equal to area of a square. Now we can find that if you see clearly, if I'm trying to just check this over here, this is A and this is also A. If I'm forming this a square of this side A, so this region is nothing but A square, right? And here to here is B, here to here is B. If I'm trying to connect this one, then this is what? This is B square, right? And this part is B and this is what? A. So this means this is what? AB, and this is B and this is A, means this is what? Also AB, right? So if we see the area of this big square A plus B side is nothing but A plus B whole square, which is equal to what? The area of this smaller square plus this area of this smaller square plus area of this rectangle plus area of this rectangle, right? So we can write this as equal to area of a smaller square whose side is A plus area of this smaller square whose side is B plus area of this rectangle whose width is B and height is, length is B and width is A, means this is AB, and area of this rectangle whose length is A and width is B, which is BA. So we can find that this is equal to nothing but A square plus B square plus 2AB, right? So likewise we can think of this A minus B whole square identity as well, can be derived with the help of this area of a square. So let's try to explore this one. Suppose we have a square of side A. Suppose we have a square of side A. Now this is a square of side A. Now what I'm taking is, I'm taking a side length B over here. Then we can find that this is nothing but A minus B. So let's try to form the just take A minus B over here as well. So and form a square. So this is what? A minus B. So this smaller area is nothing but what? This smaller area is what? A minus B whole square, right? And this bigger square area is what? This is having side A. So this bigger area is what? Plus A square, right? So let's try to join this one over here and over here. So we can find that this part is what? B, and this part is here to here is A minus B, and this is also B, right? This is also B, this is also A minus B. So once we try to explore this one, we'll get this as this bigger area, which is the area of a square having side A, which is equal to what? A square is equal to the area of this smaller square whose side is A minus B. So this is A minus B whole power 2 plus the area of this one, which is B square, and then further this area B times of A minus B as well as B times of A minus B, which is coming what? 2 times of B times of A minus B. We want the value of A minus B whole square. So once we expand this, we'll find this as A minus B whole square plus B square plus 2BA minus 2BA square on the right side, right? So we'll get this as A square is equal to A minus B whole power 2, and this plus B square minus 2B square is minus B square plus 2AB. So if I'm taking all of these things in the left, we'll get this as A square plus B square minus 2AB, which is equal to A minus B whole square. So these are the geometrical understanding of these two identities. So just I explain this for the sake of understanding purpose, but we need to just remember this result. We are going to use this identities frequently now onwards. Like this is a kind of like counting numbers. Like a children of lower grade, they knows the counting, they knows the alphabets, they knows the vowel consonants. Like that you need to remember these identities, whatever be the identity that we are going to discuss over here. Not only just remember these identity, but also you need to be like very comfortable in using this identity wherever and whenever it is required. Okay. Evaluate using identity. For example, we have given 4x minus 3y whole power 2. This is the first example. Second example, we have given, let's say, 3x plus 1 by 4y power 2. And third example that we have given is 0.2x plus 0.1 y whole power 2. We need to use the identities and find the values of this. So we can find that the first one is 4x minus 3y. This is what the two numbers difference square. Let's consider this to be a, this to be b, then this is what a minus b whole power 2. So we can use that identity and simplify this result. So how we can write this? We can write this as, this is the a and this is b, then we can write this as 4x power 2 plus 3y power 2 minus 2 times of 4x times of 3y. We'll get this as a square of 4x, means 4 and x both are in multiplication and power is for both of this number, means this power 2 will come for 2 as well as for 4 as well as x. So 4 square means 16, so this is 16x square plus 3 square 9 y square, and now this is 2 4 the 8 3 the 24xy. Now this is what the expansion of this 4x minus 3y whole power 2. Likewise we can find this result as well. So we have given 3x plus 1 by 4y. So this, consider this a as 3x, b as 1 by 4y. Then this will become what? A plus b whole power 2, and we know the identity a square plus b square plus 2ab, right? With the help of this, we can write this as a is 3x, b is 1 by 4y. So in place of a, we are substituting 3x and b 1 by 4y whole power 2. It means equal to 3x power 2 plus 1 by 4y power 2 plus 2 times of 3x times of 1 by 4y. So if we are expanding further, this is 3 square means 9x square, and this is 1 by 16 y square. Square will come for 4 as well as y. Now this 2 is going to cancel this 4 by 2 times, so this is plus 3x by 2y. Right. So now the third example also, we can use the same a plus b whole square and expand the given expression. So here we can write this as 0.2x square plus 0.1 y square plus 2 times of 0.2x 0.2x whole power 2 plus 0.1 y power 2 plus 2 times of 0.2x 0.1 y. So a square of 2 is 4, and we have 0.2. 0.2 square means what? 0.2 square means 0.2 into 0.2. We'll find that 2 into 2 is 4 and 2 digit decimal, right? So here 1 digit after decimal, here also 1 digit after decimal. So we need to put the decimal after 2 digits, means this is 0.04, right? So likewise we need to do the multiplications for the decimal. We need to take care of this decimal. So this is what? 0.04x square plus this is 0.01 y square, and this will become 0.04xy. So this is the way we can find the values, or we can simplify the given expression by using the identities. So these are the two very basic identities. Now the third identity is very important, so which you will find that most of the time in factorizations or the problems when you solve from the polynomial, that you will find that this is going to be frequently used. So the third identity is the squares of difference of any two number, means a square minus b square, which is equal to a minus b times of a plus b. This identity is very important. Firstly, when we deal with the factorizations, then we'll frequently use this identity. So we can think of, like, not only from the left to right, we always need to remember each identity from both end, left to right as well as right to end, right to left as well. So over here we have a minus b times a plus b, which is equal to a square minus b square. Okay, so we can derive this by using the multiplication of these two. If we expand this, then Upon cancellation of the few terms, we'll find that this is equal to a square minus b square. So let's see then, a minus b times of a plus b. A minus b times a plus b, if I'm trying to expand it, we'll write it as a times a plus b, then minus b times of a plus b. So if we are further expanding this, this is a square plus ab minus ba minus b square. Now we know this AB and BA both are same. Over here this is plus AB, this is minus BA, both cancelled. So we're left with A square minus B square. So we found that this A minus B times A plus B is equal to what? A square minus B square. This is the identity that we are going to use most of the time in this polynomial. So let's take an example. Suppose we have given 4x minus 3y times of 4x plus 3y. We need to find this value of this given product of these two polynomial in x and y. So you can find that this is written in the form of this difference of two numbers times of sum of two numbers, right? So this is like A and this is B. So you can find that this number same is over here, A, and this is B. So basically this is A minus B and this is A plus B. So it means this is equal to what? A square minus B square, right? So we can simply write this as, let's say A is equal to 4x, B is equal to 3y, then this expression becomes A minus B times of A plus B, which is equal to A square minus B square. Now A is 4x, so if I'm substituting that, 4x minus B is 3y, and over here this is 4x plus 3y is equal to what? 4x square minus 3y whole square. So a square of 4 as well as x square of x, so this is 16x square minus 3 square, 9 times of y square. So we can find the values of this kind of expression, the product, by identifying the identity which is settable over here. So we can find that this is of this format, like the difference of two numbers times of the sum of two numbers. So that is equal to what? The difference of the squares of two numbers, right? Okay. Now let's try to understand this identity geometrically. So let's take a site. Over here you can find that this is A minus B into A plus B. Means this is, let's say I'm taking this as length, this as breadth. Means this is product of length and breadth. So let's try to make a rectangle of length A minus B and breadth A plus B. So first I'm taking this as A. Then this part here to here I'm taking B. So this total is A and this is B, means this part is A minus B, right? And this side I'm taking A plus B, breadth of this is A and this is B. This is B. Let's try to form a rectangle. So of A minus B, this is A minus B over here and A plus B. So let me just draw the rectangle. Okay. So this is a rectangle of side. This side is A plus B and this side is A minus B. So this A plus B times of A minus B, if we see, this is equal to what? A plus B times of A minus B is equal to what? This is bigger rectangle. Let me just form the bigger rectangle. This is what? A and this is B. So we can find that this area is nothing but A plus B times of A minus B, which is equal to the bigger rectangle whose length is A and width is A plus B. So A times of A plus B, right? So here you can find that this length is A and this width is A plus B. So area of this bigger rectangle minus this area, right? So this area is what? The width is B and the length is what? A plus B. So B times of A plus B. If we expand this, then we find that this is a square plus ab minus ba minus b square, and ab and ba is got cancelled, which is equal to a square minus b square. So this way we can like visualize the identities in a like geometrical way. So this all are nothing but the areas of the rectangles and squares. Okay, so this identity is very important. We need to remember this. Now we are going to discuss problem based on the three identities that we have discussed till now. Okay, once we are able to use this appropriately, then we'll move to the next identities, which is of like sum of three numbers squares or the cube of the sum of two numbers. Using identity, evaluate. First one is 102 square. Second example is, let's say, 97 square. Third example is 95 times of 105. So here we need to use the identity and we need to find the values of this given numbers. So first of all, here this 102 power 2. So we need to use the identity and we need to evaluate this. Can we think of writing this 102 as 100 plus 2? So we can write this as 100 plus 2, right? So if I'm writing 100 plus 2 means this is what the sum of two numbers square, means a plus b whole square. Next thing is just take the squares of both number, 100 square plus 2 square plus 2 times of 100 times of 2. That will give us what? 10,000 plus 4 plus 400. So 10,404 is the value of this, right? The same way we can think of writing this 97 square as 100 minus 3, right? Or we can write this as 90 plus 7 as well. So this, if I'm writing 100 minus 3 whole power 2, means this is what the difference of two numbers square. Or we can write this as 90 plus 7 as well. So then it will become the sum of two numbers square, right? So if I'm solving this part, this is what 100 square plus 3 square minus 2 times of 100 times of 3. So this becomes 10,000 plus 9 minus 600. So 10,009 minus 600. Then this will become 9049. Right. Very good. Now think of this number, or we can use this, how we can find this with the help of identity. So can we able to use the a plus b whole square or a minus b whole square? We can't, right? So this is product of number, right? It means most probably this is either the product of sum of two numbers and difference of two numbers. Think of this is 105 and this is 95, right? Means this is 100 plus 5 and this is 100 minus 5, right? It means basically this number is like written as this is 100 minus 5. 95 is nothing but 100 and minus 5, right? And this is 100 plus 5. Wow, this is an identity, right? A minus b, a plus b. So this is very simple. We can write it as 100 square minus 5 square, which is 10,000 minus 25. Then that will become 75 and 0, and this is 9975, right? 9975. Okay. Suppose we have given 2027 divided by negative 27 square plus negative 2026 times of 2028. Find the value of this. Find the value of this. We need to find this value. In numerator we have given 2027. In denominator we have negative 2027 power 2 plus negative 2026 times of 2028. Do we need to just go for multiplication of these numbers and then further divide? This is a very big number, right? So this kind of questions we have to use the identities. what identity we can use? So numerator only one number, so we can't think about any identities in the numerator. Think of denominator. Negative square means it's a positive number, right? Okay, so this is 2027 square, and over here 2026 and 2028. There is nothing common in all. We can't think of taking anything common over here, right? But if we think this is what? This is 1 less than this number, and it means this 2026 can be written as 2027 minus 1, and this can be written as 2027 plus 1. A plus B, it means this is basically 2027 square minus 1 square. So this is 2027 divided by 2027 square minus of 2027 square minus 1 square, right? And 1 square means 1 only, right? So if we further simplify this, this will become equal to 2027 divided by 2027 square, and this is minus plus minus 2027 square, and this minus become plus 1, as 1 square is 1. Now we can find that this 2027 square minus 2027 square is going to be cancelled. So we left in denominator only 1, and numerator 2027 by 1 is this value is equal to 2027, right? Okay, so this way we can think of such kind of question can be solved with the help of identity. So now I'm giving you one question for you to do by yourself. Do yourself. Okay, so number I'm giving is 2027 divided by 2026 square plus 2028 square minus 2. So this is a square. Okay, so 2027 square divided by 2026 square plus 2028 square minus 2. So this is the question for you to solve and comment on your answer. Okay, so now we are going to move on some derived identities based on what we have learned till now. We learned only 3 identities. Now we'll try to derive some more identities from these basic identities, and based on that we'll see how we can ask the question. Okay, now let's see some derived identities based on what we have done till now. We have done 3 identities: a plus b whole square, a minus b whole square, a square minus b square. So think of like we have a plus b whole square is nothing but a square plus b square plus 2ab, and a minus b whole square is equal to a square plus b square minus 2ab. Now first see this first one. Here we have a square plus b square plus 2ab, right? Can we write this a plus b whole square in terms of a minus b whole square? As you can see, first 2 terms in the expansions of a plus b whole square and a minus b square is same. So think of writing this as just I'm writing a square b square and writing minus 2ab, but here we have plus 2ab, right? So if I'm adding 4ab, so this a square plus b square minus 2ab plus 4ab is same as this one, right? But this 3 term is going to be equal to what? A minus b whole square, right? So a minus b whole square plus 4ab is equal to what? A plus b whole square. So this is one of the derived identity with the help of 2 basic identities. Some of the place we'll use this in dealing with the polynomials. So the same way we can write a minus b whole square in terms of a plus b whole square. So can we write this as minus plus b square? Write it as a minus b whole square is equal to a square plus b square minus 2ab. So a square as a square, b square as b square. Minus 2ab can be written as plus 2ab minus 4ab. We can write it, right? Now these 3 terms become what? A plus b whole square minus 4ab. So we can write this a minus b whole square is equal to a plus b whole square minus 4ab. This is also one of the derived identity. Okay, so this is the first derived identity and this is the second derived identity. Okay, Now let's think of, okay, we have this a plus b whole square is equal to a square plus b square plus 2ab, and a minus b whole square is equal to a square plus b square minus 2ab. If we are adding both of this identity, the respective side of this identity, left with left and right with right, what we'll get? Let's see, the third one is a plus b whole square minus, plus a minus b whole square will be equal to what? You just try to add this a square plus b square plus 2ab and a square plus b square minus 2ab. If we are adding, plus 2ab minus bab got cancelled, and this a square 2 times, b square 2 times. So this is nothing but 2 times of a square plus b square. Okay, so this is another identity. What if we are subtracting both of this? A plus b whole square minus a minus b whole square. That is the fourth identity. So a plus b whole square minus a minus b whole square is equal to what? Okay, if we are trying to subtract both of this, means a square plus b square plus 2ab minus a square plus b square minus 2ab. What will happen? This a square cancelled by a square, b square cancelled by b square, this plus 2ab, and minus of minus 2ab is what? Plus 2ab, right? So we'll get this as 4 times of ab. You can just try to write separately and check it. You'll get the same result. Okay, let me just show you. A plus b whole square is equal to a square plus b square plus 2ab. I'm writing the right part. Okay, minus of this one, a square plus b square minus 2ab. If you're expanding this, what you will get? A square plus b square plus 2ab minus plus minus a square minus plus minus b square minus minus plus 2ab. So here plus a square minus a square cancel, plus b square minus b square cancel, plus 2ab is plus 4ab. So this is the fourth derived result. Okay, now we can further deduce some more result from the given identity. So just see this one, like a plus b whole square is equal to what? A square plus b square plus 2ab. Can we write the a square plus b square, right? So we can find that this a square plus b square is equal to nothing but a plus b whole square, and I'm taking this to other side, minus 2ab. So this is one of the result which is frequently used when we have given value of a plus b and a into b value, and we need to find a square plus b square. Not only this, a square plus b square can be written as this way also with the help of the second identity, a square plus b square. We can write it as a minus b whole square plus 2ab. So these two are very important result that we'll use in solving the question. For example, let's say if we have given a plus b is equal to 7 and a into b is equal to 3. Find the value of a square plus b square. If such kind of question is given, then this result is very useful, right? So we can directly substitute the value of a plus b in this, and we can get this result, a square plus b square, right? See, a square plus b square we can write it as a plus b whole square minus 2ab, and a plus b value is given 7, so 7 square minus 2 times of 3, so which is 49 minus 6 equal to 43. So if we know this identity, we can directly get this result. If we don't know this identity also, we can find the result a square plus b square with the given a plus b value and ab value, right? So what we'll do in that case, we have given a plus b is equal to 7, then what we'll do, we'll square both of the sides. Once we square both of the side, we'll get this as a plus b whole square is equal to 7 square, and with the help of identity a plus b whole square, we'll get this as a square plus b square plus 2ab is equal to 49. Now further we have given ab value which is 3, so we can substitute this over here. So a square plus b square plus 2 times of 3 is equal to 49, and we can get the value of a square plus b square is equal to, this is 6, 49 minus 6 is 43. So but sometimes if we know this derivation, means that will be easier by looking into the given situation, the problem, we can easily use this and we can find it. If we don't know also, we can go with the process of squaring and then using the given value. Now let's see another example. Suppose we have given a minus b is equal to let's say 6 and we have given a into b is equal to -1. Then find a square plus b square. So with this derived result we can find that a square plus b square is equal to a minus b whole square plus 2ab, which is what? 6 square plus 2 into -1. So 36 minus 2, which is equal to 34. Right. So sometimes we use this result as well as this result. Very important. So I'm giving you few questions to do by yourself. Do yourself. First question is, we have given a plus b is equal to -8 and a into b is equal to 4. Find a square plus b square. This is the first question. And the second question is given as a minus b is equal to 11 and a into b is equal to -10. Find a square plus b square. So these two questions are for you to do yourself and comment down your answer. Now another derived result is this one. Suppose we have given x plus 1 over x whole power 2. So x plus 1 over x whole power 2, we can consider this as a and this as b. Then this will become a square plus b square plus 2ab, right? It means this is equal to x square plus 1 by x square plus 2 times of x times of 1 by x. So we can find that this is equal to x square plus 1 by x square and plus this x and the x got cancelled plus 2. So this result is very, very important, right? This result is very, very important. X plus 1 by x whole power 2 is equal to x square plus 1 by x square plus 2. Similarly, we can remember this identity also. X minus 1 by x whole square will be equal to x square plus 1 by x square minus 2 by using a minus b whole square. Okay, because a square plus b square minus 2ab. So minus 2 into 1 by x, x got cancelled, we left with only 2. So these two results are very, very important. Okay, these two results are very, very important. So we'll see a good number of questions on this result, and I'll give you some direct result also, how we can directly find the values of like x square plus 1 by x square when we have given x plus 1 by x, or you can go with this identity as well. Suppose we have given x plus 1 by x is equal to x plus 1 by x is equal to, let's say 5. X plus 1 by x is equal to 5. Then find x square plus 1 by x square. This is the first question. So now only we have seen this result. What we will do, one way is directly we can take this both number square on either side. We'll get this as a square of x plus 1 by x. So x square plus 1 by x square plus 2 is equal to 25. So we'll get the value of x square plus 1 by x square is equal to 25 minus 2, which is equal to 23. Right. Right. Okay. Now suppose I want you to find x to the power 4 plus 1 by x to power 4 as well as x to power 8 plus 1 by x to power 8 as well. When we have given x plus 1 by x is equal to 5, first find x square plus 1 by x square, then x power 4 plus 1 by x power 4, then x power 8 plus 1 by 8 to the power 8. How we can go for this? So the process is same. Once we got this x square plus 1 by x square is equal to like 23, then again we can square both sides of this one, then we'll get the x to power 4 plus 1 by x to power 4, and again we are squaring, then we'll get x power 8 plus 1 to the power of x to power 8. So what we got x to the power 2 plus 1 by x to power 2 is equal to 23. So when we square both sides, what we'll get? This as x to the power 2 square plus 1 by x to power 2 whole square plus 2 times of x square times of 1 by x square is equal to 23 square. 23 square 529, right? So this x square got cancelled, so this is x power 4 plus 1 by x power 4, and this is got cancelled. This plus 2 goes to the side as minus 2, so 529 minus 2 is 527. Right. Now we want the value of x to the power 8 plus 1 by x to the power 8. So what we'll do, we need to square this one on both of the side. We'll get this as x to the power 4 plus 1 by x to the power 4 whole power 2 is equal to 527 square. So this will give us x to the power 8 plus 1 by x to the power 8 plus 2 is equal to 527 square. Right. So we can find the square of 527. Just multiply this and then we'll get the result. So x to the power 8 plus 1 by x to the power 8 is equal to 527 square minus 2. So once we square 527, it will come 277729 and then minus 2. So we'll get this as x to the power 8 plus 1 by x to the power 8 is equal to 277727. Okay, so this is the way that we can find if we have given x plus 1 by x value and we need to find x to the power 2 plus 1 by x to the power 2, x to the power 8 plus 1 by x to the power 8, x to the power 4 plus 1 by x to the power 4. So we can square both sides and then like we'll get this result like x square plus 1 by x square plus 2. Plus 2 will go to that side as minus. And after finding this, again we'll square and this way we'll proceed. So instead of doing this squaring both sides again and again, why can't we go for just a simple generalization for this one? So let me just give you an idea that if we have given question like this, x plus 1 by x value, then we can easily find x square plus 1 by x square. Let me just give you, let's say if we have given x plus 1 by x is equal to any number a, then we can find this x square plus 1 by x square value is equal to a square minus 2. A square minus 2. You can just see this result, why we are writing this one. So by squaring both sides, you have seen this. When you are squaring both sides, you will get this as x square plus 1 by x square plus 2 is equal to a square. If I am taking this plus 2 to the right, that will go as minus 2. X square plus 1 by x square is equal to a square minus 2, right? And again I am squaring both sides. Then this will go power 4 plus 2 will come, right? So again over here a square minus 2 whole square, then plus 2 goes to the right as minus 2 means this is a square minus 2 whole square minus 2. So why we are going to do like a step like again squaring, we can directly generalize this one. If we have x plus 1 by x is a, then we can find x square plus 1 by x square is equal to a square minus 2. Okay, and we can write this as x power 4 plus 1 by x power 4 as a square minus 2 square minus 2, right? And again we can write this as x to the power 8 plus 1 by x to the power 8 is equal to what? A square minus 2 square minus 2 this square and again minus 2, right? So we can use this for finding the values of x square plus 1 by x square, x power 4 plus 1 by x power 4 when x plus 1 by x is given. Let's take an example. If we have given x plus 1 by x is equal to, let's say we have given this as 2, then x square plus, let me take this as 3. X square plus 1 by x square is equal to what? 3 square minus 2, which is 9 minus 2 is 7. Right, then x power 4 plus 1 by x to the power 4 is equal to what? 7 square minus 2. So 49 square minus 2 is what? 47. Right, and we can find the value of x to the power 8 plus 1 by x to the power 8 is what? 47 square minus 2. Right, 47 square minus 2, which is equal to what? So just multiply this 49 and then this is 16. 4 to the 8, 7 the 56. 2209 minus 2, which is equal to 2207. So we can use this for finding the value of x square plus 1 by x square and x power 4 plus 1 by x power 4. Okay. Now suppose we have given, instead of x plus a, x plus 1 by x, we have given x minus 1 by x. We have given x minus 1 by x is equal to a. Then how we can find x square plus 1 by x square, x to the power 4 plus 1 by x to the power 4, these things. So just think of like same way, x square plus 1 by x square minus 2 is equal to a square if you are squaring both sides, right? Then this minus 2 will goes to the right as plus 2. So a square plus 2, right? So just the only slight difference in the two cases is when we have x plus 1 by x is equal to a, then x square plus 1 by x square is equal to a square minus 2. When we have plus over here, then we have to take the square minus 2, and when we have minus over here, then we need to take a square and then add 2. Right. So from x minus 1 by x we got this one. So now the process of x to the power 4 plus 1 by x to the power 4 will be the same, the previous repeated one. Okay, so we got this one, x square plus 1 by x square is equal to this. So from this we can find x power 4 plus 1 by x power 4 is equal to a square plus 2 whole square minus 2. Why minus 2? Because now this is plus over here. So again if we are taking a square, then plus 2 will come, that side goes to minus 2, right? So this way we can write this x to the power 8 plus 1 by x to the power 8 is equal to what? A square plus 2 whole square minus 2 whole square and again minus 2. Right. So we can use this result in like solving the questions, but we can directly we can solve by directly taking a square both sides as well. Okay. Anyway, so suppose we have given x plus 1 by x, x plus 1 by x is equal to a, and I am asking to find the value of x square minus 1 by x square. So over here we have given x plus 1 by x value as a, and I am asking the value of x square minus 1 by x square. So you can think of this x square minus 1 by x square, this is nothing but you can think of this as x square minus 1 by x whole square, right? So this is a square minus b square format, right? So we can write this as x minus 1 by x and x plus 1 by x. We have given only x plus 1 by x value. So we cannot find this value until unless we are getting the value of x minus 1 by x. So what we do then? We'll use the derived result. We have already seen that this result a plus b we have given, so we can write that in terms of a minus b whole square. Remember this, right? Remember this. So we can write this as a plus b whole square is equal to a minus b whole square plus 4ab, right? So we have given x plus 1 by x is a, So can we write this as x plus 1 by x whole square is equal to a square. Now think of writing this as in terms of x minus 1 by x whole square. So we can write this as x minus 1 by x whole square and plus 2. What? Plus 4, not plus 2, plus 4, right, is equal to a square, right? So what I'm writing, see, just a plus b whole square is equal to what? A minus b whole square plus 4ab, right? So here a is what? X, b is 1 by x. So 4 times of x into 1 by x and 1 by x got cancelled. That's why this is plus 4, right? So now with the help of this, we can find that x minus 1 by x whole square is equal to a square minus 4. So now a square goes to right side as root plus minus a square minus 4. So we have given x plus 1 by x is a. With that we found the value of x minus 1 by x is equal to plus minus under root a square minus 4. So if I'm substituting this value x minus 1 by x and x plus 1 by x over here, then we'll find that this is x plus 1 by x is a and this is plus minus a square minus 4 times of a, so which is basically plus minus a times of under root a square minus 4. This is the value of x square minus x 1 over x square. Okay, right. So we need to like solve this type of question for not a specific value. We need to just practice this in a general value, right? If we are able to solve this for unknowns a and b and something, then whatever a specific value we are substituting over here, that will be a simpler one, right? So let's take an example over here. Suppose we have given x minus 1 by x is equal to 3. Then find the value of x square minus 1 by x square. So you can easily say, if you remember this result, that is great, but it's not an easy task to remember each and every result, right? So we need to understand the process behind this. If we are able to derive this result, then finding of these values are easy, right? So just think of writing this x square minus 1 by x square as x minus 1 by x times of x plus 1 by x. And this x minus 1 by x value is given. We need to just find the value of x plus 1 by x. Here I given x plus 1 by x is a. Here I have given x minus 1 by x is equal to 3. So the process is same. We'll write in this x plus 1 by x in terms of x minus 1 by x. So first I'm writing this as 3 times of x plus 1 by x. We need to just evaluate this x plus 1 by x value. So over here we have given x minus 1 by x is 3. So let's take the square on both sides. We'll get this as x minus 1 by x whole square is equal to 3 square means 9. Right. Now we need to write this in terms of x plus 1 by x. Right. So we can write this as x plus 1 by x whole square. So x plus 1 by x square, that will give us what? X square plus 1 by x square plus 2. But here what we have? X square plus 1 by x square minus 2. So to get minus 2, we need to subtract 4, which is equal to 9. Right. So from this we can get this as x plus 1 by x whole square is equal to 4 goes to right side. 9 plus 4 is 13. So this value of x plus 1 by x is equal to plus minus square root 13. X plus 1 by x is equal to plus minus root 13. Okay. So we can say that the value of x square minus 1 by x square is equal to what? Plus minus 3 times of root 13. So we can say the value of this is what? Plus minus 3 times of root 13. Okay, very good. Suppose we have given to find the value of x minus 1 by x times of x plus 1 by x times x square plus 1 by x square times x to the power 4 plus 1 by x to the power 4, x to the power 8 plus 1 by x to the power 8, and this goes on up to x to the power 2 to the power n plus 1 by x to the power 2 power n, where n is a natural number. Where n is a natural number. Or we can take this as whole number. Okay, so here 2 power 1 means this is 2 to power, okay, so here we have x minus 1 by x. Here we can find that x square 1 by x square, x power 4. X power 4 means what? 2 power 2, right? You can think of this as x to the power 2 power 2 plus 1 by x to the power 2 power 2, right? And this has x to the power 2 power 3 plus 1 by x to the power 2 power 3, and so on, right? So here this is x to the power 2 power 1 plus 1 by x to the power 2 power 1, and this is x to the power 2 power 0 plus 1 by x to the power 2 power 0, and this is also x to the power 2 power 0 minus 1 by x to the power 2 power 0. So in order to solve this question, let's first try to take a simple example to understand this one. So suppose we have given x minus 1 by x times of x plus 1 by x times of x square plus 1 by x square. Then we can find that, okay, the product of these two, first two term, I mean binomial, like over here this is a minus b form and this is a plus b form. So x minus 1 by x times of x plus 1 by x is what? X square minus of 1 by x square. The product of first two is what? X square minus 1 by x square, and the third one is x square plus 1 by x square. Again you can find that the first term is x square, here also x square, minus here, plus here, 1 by x square, 1 by x square. I mean this is a and this is b, so a minus b, a plus b, right? So we can find that, okay, a minus b, a plus b means what? A square minus b square means square of x square minus 1 by x square of square, means we'll get this as x power 4 minus 1 by x power 4, right? If we have another term like, let's say, x to the power 4 plus 1 by x to the power 4, then we further get this as x power 4 plus 1 by x power 4, and here also x power 4 plus 1 by x power 4, and then further x power 4 plus 1 by x power 4. So this will give us what? Again a minus b, a plus b means a square of first minus a square of second, so this will become x to the power 8 minus 1 by x to the power 8. So we'll use this, we can find that this is this expression, and this one is like same way only, right? So we need to handle discussion in the same way, but here we have like unknowns n. So like we did over here, like a simplification of next to next, next to next, and we are coming up with the last term. We cannot go in that way in the discussion. We need to identify some pattern in the process. So let's see how we can go for the pattern. First, if we just look into the first one, let's try to look into the first one. Just ignore this part for now. This will look into the next step. The product of these two, this is x minus 1 by x is what? X minus 1 by x into x plus 1 by x is what? X square plus 1 by x square. And the second term is x square plus 1 by x square, and then next x to power 4 plus 1 by x to power 4, and next x power 8 plus 1 by x to power 8, and this goes on x power 2 power n plus 1 by x to power 2 power n. Now for n0 I have taken over here onwards we have what? N power 1, right? So here n is belonging to natural number, right? Now we can think of identifying the pattern over here. See, this is minus, because the product of this is what? Square of first minus square of second. Okay, from here we need to identify the pattern. So once we multiply these two, so I'm taking n belonging from 1 to natural number, means n is belonging from natural number, means what? 2 power 1, then 2 power 2, this is what? 2 power 2, then this is what? 2 power 3, and so on up to what? Power n, right? So we are not going to multiply it till the end. We need to just figure out some pattern in this. Okay, so once we multiply these two, once we are multiplying these two, what we are getting? This is x square minus 1 by x square, and this is x square plus 1 by x square. When we are multiplying this, we are getting x to the power 4 minus 1 by x to the power 4, right or not? So this is x to the power 4 only, right? Now see, when we multiply the first term, when we multiply the first, or I mean 2 power 2 power 1, right? We got this as x to the power 4, which is what? 2 to the power 2 form. Just try to understand this one. X to the power 2 to the power 2 minus 1 by x to the power 2 power 2. Okay, now next term is what? Just see this one, x power 4 plus 1 by x to the power 4. When we are multiplying this one, this 2, when we multiply this 2, we'll get what? X to the power 4 power 2. So by power law, 4 to the 8, we'll get 8 over here. 8 minus 1 by 8. So in this also we can figure it out. This is what? Actually this is x to the power 2 power 3 minus 1 by x to the power 2 power 3, right? So once we multiply this 2 term, we are getting what? X to the power 2 power 2, means 2 power 2 also we can think of 1 plus 1, right? This is 1 plus 1. When we are multiplying second and third, after this multiplication, what we are getting? 2 power of 3, 2 power of 3. So this is what? 2 to the power of 2 plus 1, 2 plus 1, right? So when we multiply these two, I mean x to the power 4 plus 1 by x to the power 4, we got it as x to the power 8 minus 1 by x to the power 8. When we multiply with this x power 1 by x power 8 plus 1 by x to the power 8, what we'll get? We'll get this as x to the power 8 power 2 means x to the power 16, 8 to the 16. 16 means what? X to the power 2 power 4. 2 power 4 we can write it as 2 power 3 plus 1, right? So the multiplication of this 2 will become what? X to the power of 2 power 3 plus 1 minus 1 over x to the power 2 to the power 3 plus 1. So likewise, when we multiply the 2 power 3 term, this one we got x to the power 2 power 3 plus 1. So over here we have n. So if we multiply with the just before term, what we'll get? We'll get this as x to the power 2 power n. And if there means what? Over here we have 2 power 3. 2 power 3. Then what we got? 2 power 3 plus 1. So over here we have 2 power n. So then what we'll get? 2 to the power n plus 1 minus 1 by x to the power 2 power n plus 1. So this is the answer. Right. So this kind of question is like not directly the just we use the identity and we'll get the result, but we need to identify the patterns as well. Okay, so now let's see some other type of question. Suppose we have given x square plus 1 by x square is equal to 18. Then find the value of x minus 1 by x. This is the first one. Second one is x plus 1 by x, and the third one is x square plus 1 by x square. Sorry, x square minus 1 by x square. Third one is x square minus 1 by x square. Fourth one is x power 4 plus 1 by x power 4. So for this kind of question also we can go for generalization. Just remember these things. If we have given x square plus 1 by x square is equal to a, and we want x minus 1 by x. Minus 1 by x means what? When we subtract to either side, then it will become x minus 1 by x whole square. So what we'll do, from this we can get x minus 1 by x is equal to what? See, x square plus 1 by x square is equal to a. When we are subtracting both sides 2, then right side will become a minus 2 and left side will become x minus 1 by x whole square. Right? Right. If we are subtracting 2 over here, means this is x square plus 1 by x square minus 2 means what? X minus 1 by x whole square, which is equal to a minus 2. So we want the value of x minus 1 by x, means this square goes to plus minus root of a minus 2. So when we have given x square plus 1 by x square a, and we want x minus 1 by x, means what? Whatever be the number given over here, that minus 2 and root of that. Means directly we can remember, then x minus 1 by x is equal to plus minus root of a minus 2. Right. Right. So what value we'll get over here? We have given x square plus 1 by x square is 18. So we can find the value of first one as x minus 1 by x is equal to what? Plus minus under root a minus 2, means 18 minus 2. 18 minus 2 is what? 16. So 16 root is plus minus 4. So x minus 1 by x value is plus minus 4. Now second part, we have to find x plus 1 by x, right? To get x plus 1 by x, what we need to do, we need to add 2 on either side. Then in that case, you can find this as well. X plus 1 by x whole square will become equal to a plus 2. When you are adding both sides 2, what will get? Here x square plus 1 by x square plus 2 is equal to a plus 2. And x plus 1 by x square plus 2 is nothing but x plus 1 by x whole square. So we can get x plus 1 by x is equal to plus minus of root a plus 2. So as in discussion, we have given a as 18. So we can write x plus 1 by x as a square root of 18 plus 2. So 18 plus 2 is what? 20, and 20 is 4 5. The 4 square will come out as the root as plus 2 root 5. This is the value of x plus 1 by x. X plus 1 by x, right? Now the third one is x square minus 1 by x square. We got the value of x minus 1 by x, right? And we got the value of x plus 1 by x. So we can find the x square minus 1 by x square value as x minus 1 by x times of x plus 1 by x. So here plus minus 4 means what? 1 time x minus 1 by x is plus 4 and 1 time minus 4. It means what? It means what? X minus 1 by x is equal to 4 as well as minus 4. Okay, and here also x plus 1 by x is plus root 2 5 and minus 2 root 5. So let's try to find this second, third and fourth one. So third one is x square minus 1 by x square. So we can write it as x minus 1 by x times of x plus 1 by x. So when x minus 1 by x taking 4 and x plus 1 by x taking 2 root 5. So here 4 possibilities will come. How many possibilities? 4 possibilities. When x minus 1 by x is 4, then x plus 1 by x is what? 2 root 5. Right, 2 root 5. Right. So in that case, here we can think of this as okay. So if I'm taking x minus 1 by x is 4 and x plus 1 by x as 2 root 5, then x square minus 1 by x square value is what? Is equal to 4 times of 2 root 5, which is 8 root 5. But if I'm taking x minus 1 by x as minus 4 and x plus 1 by x as 2 root 5, then in that case x square minus 1 by x square is equal to what? Minus 4 times of 2 root 5, which is equal to minus 8 root 5. Right, minus 8 root 5. But if I'm taking the value as x minus 1 by x as 4 and x plus 1 by root x is equal to minus 2 root 5, then in this case also we'll get the value of x square minus 1 by x square is what? Minus 8 root 5. So in this case also x square minus 1 by x square is what? 4 times of minus 2 root 5 is minus 8 root 5. Right. And the last case, when taking both negative, then in that case also we'll get 8 root 5. Okay. So last case means x minus 1 by x is equal to minus 4 and x plus 1 by x is equal to minus 2 root 5. Then x square minus 1 by x square is equal to what? Minus 4 times of minus 2 root 5, which is equal to plus 8 root 5. So the value of x square minus 1 by x square is either plus 8 root 5 or minus 8 root 5. Okay. Or directly we can just go for this. X minus 1 by x is plus minus 4 and this is plus minus 2. So that will come as plus minus 8 root 5. Okay. No need of writing this all sub cases. Directly also we can write. Okay. Now, the fourth example. X power 4 plus 1 by x to power 4 we need to find. We have given this one. So this is just simple. This is x plus 1 by x is a and this is just a square of that. So a square minus 2, right? Then this is equal to what? 18 square minus 2. 18 square is what? 324 minus 2, which is 322. Right. Okay, so these are the some identities, derived identities, and the problem based on that, on the like identity based on the squares of sum of two terms or the difference of the squares of two terms. Okay, so the next one is the like a square of sum of three terms or the cube of sum of two terms or difference of two terms. and some more generalized or way of writing the identities, as well as the some derived identity on the cubes of the numbers, either sums or difference of that.